Hello, and welcome to the second module in the Lifecycle Assessment and Practice series. Today, we'll be covering product lifecycle assessments with the case study project. My name is Pete Choquette, Principal and Director of Design at Epstein Group in Atlanta, Georgia. I'm again joined today by Dr. Liz Monet, our firm's expert on lifecycle assessment, who oversees all of our environmental product declaration and whole building lifecycle assessment projects. Today's learning objectives include recognizing the software used to conduct product lifecycle assessments, identifying what data needs to be collected for a lifecycle assessment and how it can be collected, choosing the right software and path to conduct an LCA, and interpreting and analyzing the results of a lifecycle assessment. Let's start with an overview of product lifecycle assessments. First, let's look at the goals of our product lifecycle assessment. Generally, these may include assessing the environmental impacts of a product, determining parts of the extraction or manufacturing process that can be improved in their environmental impacts, comparing the product to other similar products within its category or industry, and finally, obtaining the data necessary to market products based on their potential contributions to LEED version 4 credits. The LEED version 4 Building Product Disclosure and Optimization Environmental Product Declarations credit offers two options which can earn a project team 1 to 2 points. To achieve option 1, the project team must report at least 20 different products from at least 5 different manufacturers which have environmental product declarations which comply with the credit guidelines. In order for a product to count as a full product towards the count, the EPD created must be product specific, with a review conducted by a certified program operator and verified by a certified third-party verifier. A product can earn partial credit towards this count, though, as well. A generic industry-wide EPD with a review conducted by a certified program operator and verified by a certified third-party verifier is worth 1/2 of a product. For example, if the Gypsum Board Trade Association decided to do an industry-wide generic EPD for drywall, this would be worth 1/2 of a product. Finally, a project team can also submit an EPD conducted for a product by the manufacturer, which isn't critically reviewed by a third party, for 1/4 of a product. In order to achieve the second point in the credit, Option 2 allows a project team to submit documentation based on their EPD data, showing that 50% of their products by cost are below the industry average in at least 3 of the following categories: primary energy, global warming potential, stratospheric ozone, tropospheric ozone, acidification of land and water sources, and eutrophication. These results tend to come from life cycle assessments, which would typically require both the product and the industry to have commissioned EPDs, which capture all of the necessary life cycle data for both for comparison. Option 2 also allows project teams to use a USGBC approved program with multi-attribute frameworks, which we will not be covering within this course. Now that we understand a little better what is needed to earn the LEED version 4 credits, let's talk about how to begin with the life cycle assessment process.
Hello everyone, I'm Liz Monet, and I will start off by talking about should you do the LCA internally or hire an LCA practitioner. So the first question to ask yourself here is, does your company currently have the software and an employee trained in conducting LCAs on staff? If not, you might want to consider talking to a program operator or an LCA practitioner. Program operators will generally help guide you through the process of having all the necessary steps completed, including creating or finding the proper PCR, conducting the LCA and review of the LCA, creating the EPD, and having the EPD third-party verified. The program operators will work with contractors to ensure there is no conflict of interest in the process. LCA practitioners are trained and certified to conduct LCAs. If you are only looking to conduct an LCA in this process, talking directly to an LCA practitioner may be your best option. So what are the steps for completing an LCA or EPD? Here's a quick review from our previous module. Firstly, is there a PCR for the product or one that is acceptably close? If not, work with a program operator to create one, or decide to do an LCA conforming to ISO 1444, but as we mentioned, this option is worth fewer points towards the credit. Next, based on the PCR or ISO compliance, determine what information is needed, such as raw materials, transport distance, or manufacturing energy. Once you have determined what you need to consider how you will collect the data and who you need to talk to. For example, maybe you need to reach out to the plant managers who know the energy and water a process takes. Or do you have a database with that information that you need? Collect your resources and determine what else is needed for the LCA. The next step is to either conduct the LCA internally or with an LCA practitioner according to either PCR or ISO standards. Then you will need to have the LCA critically reviewed by a third party. Finally, if you are pursuing the full credit, you will need to create or have created an EPD and then have it verified by a third party. So let's talk about a few popular LCA software options for products. There are many additional products out there, and we are not trying to endorse any specific product, but would like to give you a quick overview of some of the popular options. First, the Bees Online tool. Bees is released and maintained by the National Institute of Standards and Technology. It looks exclusively at building materials and has a set database of generic building materials. EIO LCA is a free tool created by Carnegie Mellon. The tool is based on the Economic Input-Output Lifecycle Assessment, or EIO LCA method, which estimates the materials and energy resources and the environmental emissions from activities in our economy. It looks at systems such as carpet and rug mills instead of the actual carpet. SEMA Pro and Gabby are both commercial softwares which are able to conduct LCAs for a specific product based on a built-up lifecycle inventory database. There are many other available options which we do not have time to discuss in our presentation today. If you are working with a program operator or an LCA practitioner, they will help you find the software that best suits your needs. Now let's go through an example of a product LCA. Our case study will look at some examples of generic flooring options. Okay, so let's take a moment to explain why we chose Bees for this case study. Bees is a free and easy tool to use. It's entirely focused on building products, and we can easily dive into the background and LCA process without jeopardizing proprietary data, and it is mostly comprised of generic products. Because of this, however, it could not be the software of choice to do a complete LCA for lead points. It does not adjust for product variations, such as anything that would make a product exemplary. For example, a flooring that lasts much longer than other floorings. Here we have also listed a link to the website. I encourage you to take a second here and pull up the website in order to follow along with us. As a brief overview, the Bees tool looks at both environmental performance and economic performance of the materials and then weights them to come up with an overall performance score. However, for LCAs, we're only considering the environmental performance. The database within the tool has the approximate information on the environmental impacts from processes related to a product. Such environmental impacts include those shown, with impacts varying from global warming to indoor air quality to habitat alteration. Based on how these impacts are weighted against each other, the overall environmental performance score is computed for the product or products. Okay, hopefully you've had a chance to pull up the Bees tool now if you would like to follow along. Once we're at the home screen, we'll want to select Analyze Building Products. Please feel free to return at a later time to view the full tutorial. Here are some analysis options you may see in other tools and some you may not. If we look at the environmental impact category weights, we can see the impacts we saw 2 slides ago. Here is a pull-down menu that allows you to select a few options for weighting techniques. The default here is the Bees stakeholder panel, but you can also input weighting that is appropriate for your geographical area or process concerns. Here you will also see the Tracy method, which is a US method developed by the EPA, which is also found in other software. This is often used as the default method for US projects, and a given PCR may prescribe this or another method to conduct the LCA. For now, we'll just leave it on the default, which is the Bees stakeholder panel weighting. Next, we see the performance weighting for the environmental and economic performance. This will give you an overall performance score for the product or products. However, since we are only focused on the environmental impacts today, let's go ahead and change the environmental performance weight to 100% and the economic performance weight to 0%. You'll also see here the discount rate below, which is related to economic performance over time. But since we are ignoring economics here today, we can go ahead and ignore that as well. Next, we can select the category of building materials we would like to compare. For flooring systems, we'll want to select interiors, then interior finishes, and finally floor coverings. Before we move on, let's take a look into the possible materials we are selecting. If you clicked the View Products list, a pop-up window should appear. Okay, let's click through the product list and find interiors, interior finishes, floor coverings, and generic nylon carpet. When we open up this file, we can see at the top of the file the product selection and description. Here we see the functional unit described as an 11-year life for broadloom carpet and a 1 square foot area. The following materials, energy, emissions, and such are based on those assumed values. Here we will also see the system boundary for nylon broadloom carpet. The functional unit and the scope or boundary should be outlined in the PCR for a product. Looking at the boundary conditions, we can see the stages of a product we have discussed. Here we see the raw materials. Looking into the file, we can see the raw materials that contribute to the environmental impacts such as nylon 6,6 and limestone. Next is the manufacturing process. We can see the assumptions made here for this product, including items like the solid waste from the manufacturing process and the approximate transportation of raw materials to the manufacturing facility. Moving on, we'll note that the transportation to the retail facility or project site after manufacturing is modeled as a variable in this simulation. No distance is specified, but rather we'll see later that the user can designate an approximate mileage. Now that the carpet is sold, we see the installation assumption, including the amount of glue used and the wasted materials due to installation. We can also see the use stage assumptions, such as the useful life of the product and VOC impacts from carpet off-gassing. Lastly, we see the end-of-life narrative, which discusses the average recycling rate of carpet and that the rest of the product is assumed to be landfilled. Okay, go ahead and close the pop-up window. Now that we've looked at the sort of background data which needs to be collected to conduct an LCA, let's compare some materials. Let's hit next to enter the materials we'd like to compare. Here you'll see a list of product alternatives for floor coverings. We're going to compare 4 generic floor coverings. Go ahead and select the generic ceramic tile with recycled glass. Once you click the material, the product details will pop up showing the variable for transportation distance from the manufacturer. We'll go ahead and leave these as the default for all the products we compare. Once you see this, click Select Alternative and you will see the product appear at the bottom of the screen. Select the other 3 material alternatives in the same way. For this case study, we're comparing generic ceramic tile with recycled glass, generic linoleum flooring, generic nylon carpet broadloom, and generic vinyl composition tile. Scroll through the list of product alternatives to find all of these options. Once all of the materials appear below, hit the Compute button. Once the results have been computed, which is generally very quickly, an option will appear to let you view the reports. Okay, so now we're viewing the performance results. In the upper left corner, you'll see a few options, including summary graphs, life cycle stage graphs, environmental flow graphs, and embodied energy graphs. Because we're focused on environmental performance today, we'll go ahead and change that pull-down menu to environmental performance. Now you should see the graph produced below. On the left of the graph, you will see a score, and that's in points per unit. It's important to note that the higher the score, or points per unit, the worse the environmental impact is. At first glance, we can see that nylon broadloom carpet has the worst environmental performance, or the highest score. If we look a little deeper, we can see on the right side of the graph that there are a number of different environmental impact factors, such as acidification, ecotoxicity, or smog. You can also see that those are represented in the graph here. We will also see later that we can break these up and look at them more specifically. Next, however, we'll take a look at the life cycle stage graphs. Here on the right side of the graph, we can see that the scores are broken up based on the stage or phase of life. So we'll see the raw materials, manufacturing, transportation, use, and end-of-life phases. A quick look at this graph will show you that all of these options have significant impacts coming from the raw materials phase. We can also note that in the case of these products, the transportation, use, and end-of-life phases are relatively negligible. At the bottom of that chart, we can also see the exact numbers. This makes these options easy to quantify and compare. Again, we want to note here it tells you that lower values are better. Next, let's delve a little harder into a specific environmental impact. Here we'll look at global warming. So if you select the environmental flow graphs and then the drop-down menu for global warming, you will see the chart we have produced below. You will also note that the score is no longer in points per unit, but rather in grams of CO2 per unit. This is a CO2 equivalency. So on the right hand of the graph, you can note that there are a number of things that contribute to this CO2 equivalency. If we look below the chart, we will see all of these attributes with the CO2 equivalency number listed beside it. Again, these scores are reported in CO2 per unit, and that's the functional unit. So below we will see the CO2 contributing factors, which are computed in CO2 equivalency. One thing I'd like to draw your attention to here is the negative value reported for linoleum. A value of negative 400 grams of CO2 per unit is reported for carbon dioxide biomass. This is interesting because what it is indicating is that in some way linoleum captures CO2. Here we can also note that the most significant impact comes from CO2 from fossil fuels for all of these products. Okay, next, let's look at a different type of impact, human health cancer. So this is related to how often a product leads to cancerous effects. Here we will see that nylon broadloom carpet is actually not the worst, and in this case, tile with recycled glass is. For this environmental impact, we can see the categories are broken up into toxins like arsenic, lead, and dioxins. As a tile manufacturer, you could look at this and see that you have a great possibility to try and reduce your unspecified dioxins in order to reduce your human health cancer impact. Okay, so that was a brief look at some of the impact factors you can look at in bees. I encourage you to take some time to look through other impacts and look at some other building materials to see how they perform. Additionally, with LCAs, it's important to discuss both weighted and non-weighted results. Weighted results are often referred to as endpoints. Weighted results make it easier to compare products overall by using aggregate indicators such as a score. We saw this in the earliest results slide, and it gave us a quick view that carpet would perform worse in many of the categories to follow. However, of course, a weighted result is based on a weighted system, so that system can be manipulated. Say, for example, human health cancer impacts was the most important factor to our client. If that were the case, tile would perform the worst. There are many standards for how these factors can be weighted, but it is known that weighting factors can change the overall results. Non-weighted results are also known as midpoints. These results are physical indicators, such as we saw in some of the later slides, including carbon dioxide or greenhouse gas emissions. These can compare products by indicators, but it's hard to compare an overall environmental performance. When we look at results, such as these are from other LCAs, it's important to note that less is more. In this case, less impact is more sustainable. You can go ahead and take some time to browse through the other results in bees. Look at the product sheets to get more information. This can help you understand how a product is performing how it is. Maybe it takes an incredible amount of energy, and therefore its manufacturing process is highly intensive. Knowing this as a manufacturer can help you understand that this is increasing your environmental impact by a great amount and could be a place where you could save energy and environmental performance. Another great thing to do while you're on bees is to test some other distances or products to see the impact. How would a greater distance with a heavy product impact the results? How about including a product that has a longer lifespan? I encourage you to explore this curiosity and see what the impacts are. Okay, let's take a moment to reflect on and review what we have learned today. In this module, we learned about the lead credits related to product LCAs and how we can achieve them. We learned about the process to conduct an LCA and an EPD. We also talked about the background data needed to do an LCA. And lastly, we talked about how to interpret the results of an LCA. Okay, lots of information. Let's take some time to review with some questions and answers. How much of a product is an industry-wide LCA worth? As outlined by the LEED guidelines, a generic industry-wide LCA is worth half of a product. If a product team only used products with critically reviewed LCAs, how many products would they need to document? Critically reviewed LCAs are only worth 1/4 of a product, and 20 products are needed to earn the credit. This means if all of the products the product team submitted were critically reviewed LCAs, they would need to provide 80 products to reach the credit. If a product team only used products with third-party verified EPDs, how many products would they need to document? Third-party verified EPDs are worth a whole product, therefore 20 of these products could be submitted for the credit. A project team needs to document products from how many manufacturers for option 1? They need to document products from at least 5 different manufacturers. What categories are not used to measure impact reduction for option 2? Please select all that apply. Human health and fossil fuel depletion can be important indicators of a product's environmental impact, but the five other environmental impacts are the ones specified for option 2. How many categories need to be below industry average to count for option 2? 3 of the 5 categories need to be below industry average for option 2. Okay, what % of products by cost need to be below average in the 3 out of 5 categories for option 2? The project team needs to submit 50% of the products by cost as below industry average. What is the first critical step in starting an LCA? The first step when considering conducting an LCA is finding or developing a PCR. What life cycle phases may be included in the LCA? Please select all that apply. And the answer is all of these phases may be included in an LCA. The scope should specify what phases are required to be included in the LCA. Why would you want to choose a particular weighting system? Again, select all that apply. Possible reasons for choosing a particular weighting system for an LCA could be based on regional priority, such as, say, water scarcity, or to compare with other product LCAs. Option 2 is based on environmental metrics, but a weighting system would produce an overall score beyond the environmental metrics. Lastly, true or false, a product can have zero environmental impact. Okay, so this is a little tricky, but theoretically it is true. If a product were to produce as much negative impact by becoming an energy source, absorbing enough carbon dioxide, such as what we saw with linoleum, or being completely recycled, it could theoretically have no impact. However, this is unlikely. This completes the module 2. Our next module will cover a case study for a whole building life cycle assessment. If you are interested in following along with the whole building life cycle assessment as we learn, I highly encourage you to download the Athena Impact Estimator software. Otherwise, you may follow along as you have with the slides today.